Okay, so this is the correlation example. Now, this example, as per the last example, is really just to kind of illustrate the idea of correlation. So again, I'll show you how to build things up. Then we'll do the actual correlations, and we'll show you how Excel has functions to do all of this. So kind of in practice, you really wouldn't be doing this. But it's just, if you don't understand the material on page 154, 155, this might help a little bit. So we're looking at the correlations between the SAT score and the graduation rate. So let's just delete anything that's not a SAT score or a graduation rate. And let's just kind of clear this first column. Now, and let me just remove that. Now, the idea is if the SAT score and the graduation rate, they're not related at all for these colleges, then there should be a correlation of 0. If higher SAT scores generally lead to give higher graduation, then it's kind of, there's going to be a positive correlation. If lower SAT scores give higher graduation, then there's going to be a negative correlation. So it's just how the variables correlate together. So let's do this, let's kind of remove, hide some of the rows. So we'll just have the top 5 and the bottom 5. And you can just do format, hide and unhide, hide rows. So now we've got a lot of rows hidden, so we can kind of see what we're doing. So let's just kind of work out a few things. First, we really need to calculate the mean and the standard deviation for these values, because we're going to utilize these when we calculate the correlation. So we're going to calculate the mean. Let's tell you what, we'll leave the kind of the standard deviation for the moment. I want to kind of do it manually, a little bit unlike the book. So let's just do average, and this is for the median SAT, and the same with the graduation percentage. Now, actually, the book has graduation as X and SAT as Y. So I'm consistent with the book. I'm just going to kind of swap these around. Okay, and actually I will calculate the standard deviation. I think we'll just do it like the book to avoid any confusion. So again, and we're going to use we're going to stick with the sample value. So we're going to do sample standard deviation for graduation, and then for the SAT. So again, I just go to the right, and we've got it in the C column. Okay, so now what we're going to kind of calculate is we're going to do X minus mean X. Now, in fact, what I was thinking about doing is then doing X minus mean X and then squaring it and calculating the standard deviation for X manually, but that's kind of a lot of extra work, so I think we'll just stick with the book. And we have Y minus mean for the Y. So we're just basically mean centering these variables. We're subtracting the mean from these variables. So for each of these, so graduation, we subtract the mean. And of course, we want to have the dollars so we can drag it down. This X minus mean X. And we're going to do exactly the same for the mean Y. So we subtract each value from the mean. And then we go all the way, select everything and Control D to drop down. Now we have an additional column, which is going to be, and this is we call this the sum of kind of cross sum of squares. That's just the x minus mean x multiplied by y minus mean y. Now, conceptually, the idea is that if x is above its mean and y is above its mean at the same time, then this product is positive. If they're both negative, then it's also positive. But if one is negative and the other one is positive, then it's negative. So, i.e., if x is above its mean and y is above its mean, when y is above the mean, i.e., there's a positive relationship, then we get positive values. If they're kind of in the opposite direction, then we get negative values. So this is just putting in algebra the kind of the concept that if one is high when the other one is low, then the numbers are liable to be negative. But if they're both high together and both low together, then the numbers are liable to be positive. So let's kind of do the multiplication. So it's going to be this times this. And we're going to drop down, Control D again. Now we're going to calculate the sum of these cross products. So this is just going to be the sum of all these values. And the thing is, again, this gives the sum of all these cross values for the covariance, but a little bit like when we calculated variance, you know, we don't want the state where we have the bigger the data set, the larger the value. So we divide by the number of items in the data set. And if we're correcting for bias in the sample, so anything with a sample, we divide by n minus 1. And again, if we're not doing much in the way of statistical tests, it really doesn't matter. It really doesn't matter which one we use. And in fact, for correlations, it doesn't really matter at all. But let's just kind of go through this. So we just count the number of values we have. So that's just going to be counting the number of rows. So we have 49. And my covariance is going to be the sum of all my squares divided by, and we're going to use the sample, so it's going to be this minus 1. Voila, and I get the same as the book, which is good. I'm also going to do covariance, you know, using the Excel function, and it has a covariance function equals covariance. And you see we've got separate for the sample and the population, so we're going to pick the sample, what it would be if I clicked on it properly. And here I just kind of select my x's, and I select my y's. So, you know, in a business context, if you're just looking at two variables that are related to each other, then this is where you do it, the correlation, the covariance. And you see it's exactly the same result as my build-up. So again, if you're going to ever use this in practice, this is the way to do it. This example is purely just so you kind of understand the book material a little bit more. Okay, now the correlation is going to be the covariance divided by the two population standard deviations. So the two sample standard deviations. So let's just do covariance divided by this times this. And this gives us a correlation. So just again, correlation again, look at the formulas on page 155 of the book. The covariance, the correlation covariance divided by the standard deviation for x times by the standard deviation for y. And interestingly, each of these standard deviations has a square root of n minus 1. And the top has a kind of n minus 1. So that all kind of cancels out. So that's why things don't really matter whether you use a sample or kind of population for the correlation. So the correlation is 0.564, and let's just do correlation Excel. And it's going to be exactly the same as with the covariance function. But you notice now, as I said, the sample and the population are the same. So we get, it doesn't really matter. So that is the correlation. So we proved like the correlation between the graduation and the median. SAT is pretty decent. 0. Generally, you would say in correlations, 0.1 is, and this is a rule of thumb I use in my stats classes, is small. 0.3 is medium, and 0.5 would be large. You know, not larger, large. And a 1 in either direction would be absolutely perfect. But that means we actually have no error, and it's a straight line. So that's like not a realistic situation. Okay, so I will just kind of, you realize by now I hate leaving things badly formatted. So let's just make everything 12. And we want some lines underneath here. And I would actually match that with some lines underneath here, so the calculations are below, separated from the data table. Okay, let's make that a little bit wider. Okay, so that's looking much, much better now, and that is our correlation example, our first correlation example.